Good morning. I don't know. Let's see. Maybe people are going to miss this. Let's put the recording on. So that's on standard. We can just check something. Sorry, when you're watching this. Um, I'd like to fiddle with the settings to get the best possible out of it. Okay, so that's now up the resolution. Does that affect it on the recording? I want to get you the best, if you see that circle, you want to, see it. Webcam, we can just go, goodbye. You don't know. Ah, it's a little bit funny. Oh, no. Happens. Waiting. Start playing. Okay. Put the text. Good morning, Emma.
Morning, sir.
Put me on. There we go. How's that? Should I have the vocals like that?
What, sir?
I don't know if anything changed there. I always play with these little settings.
No, nothing changed.
Okay. Welcome, Eric, and presumably Daniel. James has joined and lined himself up for a birdie. Eric was going to say hello, then I don't know.
That's it.
Where's everyone? Keen to get into those circles. Welcome, Scott. How are you doing?
I'm fine, thanks, sir.
Good, good. Welcome, Renee Louis.
Thank you, sir. Happy birthday, sir.
Thank you very much. It's a great day. Welcome, Manewa.
Happy birthday, sir.
Thank you, thank
Happy
you.
birthday, sir. Happy birthday, sir.
Yay. Welcome, Indy. Welcome, Somi. Oh, and Anna.
Hi, sir.
See, that's the sound of somebody who's got up this morning, had a good walk. I mean, just sets you up for a good day, doesn't it, Somi?
Yes, happy birthday again, sir.
Thank you again.
Oh,
Welcome,
happy birthday,
Connor.
sir. Happy birthday, sir.
I'm doing very well, thanks. How are you doing?
Happy birthday, sir.
Thank you, thank you.
So Ali has load shedding, so she can't join the call.
Okay, thanks for letting me know. This load shedding, I must say I'm busy. I've got my UPS, so I can last about 5, maybe 10 minutes on load shedding, and now I'm looking at investing some sort of backup solution. We need to just figure out. Otherwise, we have like last Friday. Okay, so what we're doing today is we're doing 5 theorems in one day. So you're ready. And the reasoning behind this is our last lesson, I think, and you move into exams. And then we are continuing this section at the beginning of term 3. But when we return to it in term 3, I want us to just remind ourselves of what we've been doing and pick up and not suddenly learn something brand new. So welcome, Zanande. What we're going to do is really go for it, and welcome, Bukle. Okay, so let me share here. So be ready to write down quickly. Remember that you've got access. Is that Alex and like
Yeah, so
making
Alex,
himself look
it isn't working.
presentable? Okay, so always good to be presentable for the lesson. I like it. So, where was I? Okay, so, lost my train of thought. Here's the Cami thing. Okay, so we're gonna run through these fairly quickly. Now, remind you, you've got this workbook. You've either got a printed copy, or you printed one for yourself, or you have access to it on your device. And so therefore, that's why I'm not necessarily going to leave enough time to write down all these examples in full. But I think there are 5 things that we're looking at today. The first one has to do with cyclic quadrilaterals. So we already know what quadrilaterals are. Quadrilaterals, I'm not even going to ask, just it's some sort of shape that's got 4 sides in it. Doesn't have to be a square, rectangle, any sort of, those are very special quadrilaterals, but it's just got 4 sides. And cyclic, that I'll circle here, cyclic relates to a circle. So cyclic quadrilaterals are just quadrilaterals where the 4 vertices are on the edge of the circle. So reminder that this thing here is a vertex. So the kind of the corner of any shape of a triangle, quadrilateral, pentagon, anything. Okay, so that's what a cyclic quadrilateral is. Just touches the edges of a circle. And if we have a quadrilateral that's cyclic, there's some special properties to it. Welcome, Noah and Sponga. Okay, so if we look at our cyclic quad, there are 2 theorems that we're going to see. If we take any cyclic quad, so try and scribble one down quickly. So if we've got A is given a circle, or if you've got your booklet, then you can just add it to your booklet. And we add in a cyclic quadrilateral. So in other words, a quadrilateral that touches the circle like that, touches it at what we're going to call A, touches it at B, at C, and at D. Then by a miracle, and we'll look at this maybe next term, but next year we revisit this and see why this works. But the opposite angles add up to 180 degrees. So this angle here at A plus the angle at C add up to 180. And our reason, without this pesky apostrophe, is opposite angles of cyclic quad. Now there's a question that I got you to do earlier. And it's way up here. Let's see if I can find it quickly, and then we'll come back to where we were. And where was it? This one here, question C. I don't know if you can remember it, but we were doing angle at center equals twice angle at circumference, and you found this angle. You said, oh, well, that's 95. Well, that's fine. We can get this angle here, X. And then to get Y, you said, oh, well, let's work out what O is and then go and get Y. Whereas now you could look at it differently and say, there's a cyclic quadrilateral. So if we're given this value X, we can easily find angle Y because these are opposite angles of a cyclic quadrilateral. Whereas when you did this question, you didn't know this theorem, so you couldn't apply it. Okay, so that's our first theorem. These are all cyclic quads. Okay. So if you were given, so let's do one quick example, because this is, in fact, let's just jump to the exercise. Let's try and figure out, fingers on buzzers, what if H is 83, this is a cyclic quadrilateral, what is the value of X and how are we going to find it?
It's 83, sir.
83. Okay. So if you say that X equals 83, what would your reason be for that?
Opposite angles of a cyclic quadrilateral.
Okay. So our reason's definitely opposite angles of cyclic quad. But what do we know about opposite angles of a cyclic quad? What are we just looking at? I know it's brand new, that's why I'm pausing to say, what's special about the opposite angles? It's not that they're equal. What is our theorem?
Add up to 180.
Sorry, sir, it's 97.
Yeah, add up to 180, exactly. And it's so easy to start going, oh, well, opposite angles are cyclic quad. It's like vertically opposite angles. They're equal. No. They add up to 180. So therefore, what does x equal? Oh,
97.
so we can't hear or see your screen. Okay, I think it's just you, but you can't hear. I don't know why you can't hear. You can't hear me. Oops. Yeah, so I'm just gonna reshare that screen. Sometimes that helps. Present. Let's just. Okay, that will hopefully help with the screen sharing, but I'm not sure about the volume. Oh, there we go. That's our first theorem, and x is not 83, but x is something closer to 9. No, what is it? Is it 97?
Yeah, so it's 97.
Cool. I was reaching for my calculator. Okay, so that's our first theorem. Now, the second theorem to do with cyclic quads. And as I said, we're going through this quite quickly because it's really about you applying these theorems. So if you apply a few today, then that's great. And we're going to revisit this next term because I know a lot of you are thinking, well, I don't want to think about circles. I want to think about the exam. And that's fine. I know you're changing mindset. So let's look at this cyclic quad. If we have a cyclic quadrilateral, so we've got a quadrilateral that's sitting at all 4 points of the circle on the circumference, and we extend this line like we would do for the exterior angle of a triangle. Think if we had a triangle and we extended, we had a theorem that said this angle equals this angle plus this angle because of exterior angle of a triangle. So this is a similar idea. Now, let's take some numbers. If this angle at P, let's say for argument's sake, just for an example, was 100 degrees, what would angle M1 be? What would this opposite angle of the cyclic quad be?
80.
80 degrees. Okay, so we know that opposite angles add up to 180. So that would be 80 by way of example. If that's 80, what would this other angle on the straight line be? 100. Because angles on a straight line add up to 180. So we can see from this that whatever this angle is here, the exterior angle is always going to be the same angle. Because if this were 150, this would be 30, and then you do angles on a straight line to get you back to 150. So the exterior angle of a triangle, so if we just take that bit out there and just leave it with our colors and say, it's always going to be equal to the opposite interior angle. So the reason is quite simple. It's just exterior angle of cyclic quad, similar to we had that one of exterior angle of triangle, but this exterior angle is always going to be equal to the opposite interior angle. I'm just going to put another line here, even though I've got the colors, just to make sure that that looks different to that. Okay, so there is no doubt where was the example of that? Here we go. So if this is 110, what is the value of x?
$110.
110, right? What's your reason for that?
Exterior angle of cyclic quad.
Exterior angle of cyclic quad. There it is. And what's nice about our booklet is just rewind and say, there it was. The reason is in brackets and bold always above exterior angle of cyclic quad. And this is why you rewrite it. So those are cyclic quads in a quick nutshell. Let's go onwards, upwards, and to practice those I don't want to go too in depth, but I want to make sure you practice some. So I just want you to practice one of each of those, but I want this one was the one I picked out. Okay, so B in the first exercise, C in the second. Okay, these are mixed exercises that we're coming back to. Okay, so our second lot of theorems. So I said we're doing 5 today. We're going nice and quickly. I like it. It's warming me up in this cold Makanda weather. And our second one has to do with tangents. Okay, what is a tangent? Not like when I go off on a tangent, like what is a tangent?
It's a line outside of the circle, sir, but isn't it the same length as the diameter?
Okay, so a line outside the circle. I definitely like that idea. But in terms of length, not quite sure about the length because like here's a tangent here. And it doesn't matter if I extend it, it's still a tangent. If I extend it, it's still a tangent. If I extend it, it's still a tangent. If I cut off that extension, still a tangent. Okay, but it is outside the circle. Except not quite. We need something else a little bit more. Sponga looks ready to go.
Oh no, sir. I was just gonna tell you that Somila's iPad kicked her off Zoom, so now she's with me.
It's
Google Meet, sorry.
Whatever, doesn't matter the product. Thank you. Okay, so then the two of you can contribute. What do you think this tangent? It looks like it's outside the circle, except not quite outside the circle. It's not outside the circle and it's not inside the circle.
Yeah.
So what's special about a tangent?
That it's not inside or outside the circle.
Isn't a tangent from one side of the circle to the other side?
Okay, so if we have something like
Oh, it
this,
touches the edge of a circle, Dad.
okay. Okay, so this here is just for reference. This is a chord, but yes, it touches the circle just once. So there it is. It just touches it once. A chord is inside the circle and touches both. And if you had something like this would not be a tangent because it's touching the circle twice. Okay, so it touches it once. Now, our first tangent theorem says that if you have a tangent and it touches the circle here, and that happens to be the radius, then the angle between them is always going to be 90 degrees. And the reason for this is, I think, one of those nice ones to remember because it's tan rad. We've got a tangent perpendicular to the radius. So remember that sign there, just for reference, that means perpendicular, which means 90 degrees. Okay, so this is our next theorem that we're going to practice. So let's go for question A. How are we going to find out what x is? Bring it.
So surely,
James, yeah.
so you can see that, like angle B there. Angle B
there,
is like
yeah.
90 degrees there.
Cool. So what's your reason? So I'm going to write here OBT equals 90 degrees. Reason. Sounding good, James. What's the reason?
Um,
Let me scroll up so it's there for reference. Who's it?
That's right.
Tan perpendicular to rad. This thing here in brackets is always going to be our reason that we're using. So new reason in the bank and our toolbox is tan rad. Okay, so if that's 90 degrees, then we look like we're almost home. What's the last step?
so angles in a triangle. So
Beautiful. Okay, so there now we suddenly see, there's a triangle. So we're going to find out what x is. X is 55, give or take, right? X equals, that seem about right? 55, does that get us to 90? Angles in triangle. Okay, so not a direct, I doubt you're ever going to be asked what's the angle at B. It's always going to be one more step that you need to do. Okay, so one to practice on that. So you're on 3 questions to do so far. Okay, let's keep going. If we have a circle, so our second last theorem of today of flying through theorems, remember that we've got, I think we'll probably have close to a full week at the beginning of next term where we're going to look at these, but also see how far down the booklet we are. We'll have finished all our theorems by now, but they're going to get more complicated in how we apply them. So if we're given a circle and we're given some point outside of the circle and we draw 2 tangents. So we draw a tangent over there that touches the circle here, and we draw another tangent that is along here and it touches the circle here, then the distance from that point to where it touches the circle is equal on both sides. So this line up to that point is equal to this line here. So if we call this A, B, C, then what we know is that AB equals AC, and our reason would be tangents from same point. Now, how this question is, or not, how this theorem, I should say, is often used is if you were to add in this line here, what type of triangle have we just created?
Isosceles, sir.
Isosceles, no, is on the money. So we've created an isosceles triangle, which means that this base angle must equal this base angle as well. So although it's tans from same point, and you can shorten that to tans from same, and you can even write PT instead of point, not with a dot though, from same point, or tangents from same point. Again, the theorem, the reason clearly matches what the theorem's saying. Tangents from same point, although they're equal, it's mostly used to form an isosceles triangle. So there was, here, let's start with question A, and just starting with angle A here. We create an isosceles triangle. So we've got these 2 tangents that come from the same point. So we know that this line must equal this line. So therefore we've created an isosceles triangle with this side at 50 degrees. How do we work out what angle A is then?
180 minus 50 divided by 2.
Cool, love it. 180, thanks Ronaldo. 180 minus 50, and then you divide that by 2, so you get those 2 angles. Now in your reasoning, it's like we're joining a whole lot of reasons in one here. And it's one thing I still haven't got my head around, because I'm very rigorous in how I write things. So I would love you to write AP equals TP, tans from same point. Therefore, APT is an isosceles triangle. Therefore, this, but you don't need to write it in 100 million reasons. There are 2 crucial bits you need to mention. You need to use tangents from same point. And just say isos triangle. So there are 2 reasons that you're going to use to get A. Tans from same point, I really want to see there. And we also want to see that you recognize, therefore, it was an isosceles triangle. The third reason is angles in a triangle, but you don't have to write that. But make sure you've got this reason, and you've mentioned this word isosceles somewhere to get A. So they kind of 3 reasons, but 2 that I want to make sure that you jot down. So you say, okay, A equals 130 divided by 2. So I think we get 65 degrees, but double check that. But just to make sure you've got both of those reasons down, because it's going to come up so often. I mean, here there's going to be another isosceles triangle. So for this one, please just finish off A. That's it. I don't want to, B is a nice question, but I don't want to give you too much. Basically, 1 question per theorem to finish off this term's work on circle geometry, to make sure you do that. I said do, and then carry on with your exam prep. Okay, so our last theorem for today is tan chord. Now, when you see a tangent, it's more often than not tan chord. It comes up so often in a question on circle geometry. There will be a tangent and there will be a chord, and you will be using tan chord. I don't know, it's just one of those theorems that comes up so often. So let's have a look at it. We've got our circle. So let's highlight our circle. You'd think I could draw better circles, wouldn't you? I even bought a circle maker. Okay, so this one here says that if we've got a tangent, see, here's our tangent, and we've got a chord. So I'm going to choose this chord over here. Then the angle that's between the tangent and the chord, so this angle here is sitting between the tangent and the chord, is equal to the opposite angle. So in terms of how I've talked about using my fingers and going, put your fingers or your pencils on the circumference of the circle. The 2 points on the circumference I would think of are here, because there's where the tangent touches the circle, so it must be an important point. And we've got a chord. So our chord is this line that goes across here. And we're saying, okay, so we've got our 2 fingers there. The one angle that gets created is down this side between the tangent and the chord. And the other one is just starting there. Where can you draw angles? Well, you could also draw an angle across over there and over there. So starting from those same 2 points on the circumference, we can create this angle on the other side of the circle, and tan chord says that those 2 must be the same. So similarly, and I'm going to jot this down, but then I'm going to rub it out of this diagram so it doesn't get too complicated. This angle on this side is created from the tangent. So it's from this tangent and this chord, and we could create an angle in the opposite segment. So we could create an angle by going there and from this point across there. So it must be equal to that side. But I'm going to remove all of that. So we've just got one example. So we've got a tangent and a chord. So if we've got a circle and we create a tangent and we create a chord, then the angle on the outside must be equal to, starting from those same 2 points from the chord created on that side, that must be equal. And it doesn't matter if this angle is acute or in this case, it's obtuse. The same thing applies. We've got a tangent. Here's our tangent. We've got it touching the circle over here. And we're going to create, we've got a chord. So let's look at this chord over here. Let's make it in green so it matches. So we've got a chord over here. To create that chord, we touch the circle on here and here on the circumference. So this angle that's between the tangent and the chord is, where were we? Here, starting from there and there. I wish I could draw it at the same time, but I haven't figured that out yet. So you go to the opposite side, and therefore this angle over here is equal to that angle. So that's tan chord. Some people say it looks a bit like a windsurfer. I don't know. I guess you need a bit of imagination. Okay, so let's run through one example. A. Pause if you've spoken already. Give those people that are a bit slower to get to the unmute button. What is the value of X? Who's there? What's the value of X? Is it random name picker time? Scott, are you with us?
Yeah, sir.
Cool. Okay. So, what is the value of X? We're going to use tan chord. No question here. Do you see a tangent in the diagram? Scott, do you see a tangent in the diagram?
No, sir.
No. Do you see the diagram? Do you see this question A here?
Oh, sorry, I was looking at the wrong question, sir.
Okay, so
No,
do you have it? So here's your tangent over here.
Yeah, sir.
Cool. Okay, so what's the value of X?
So, I think it's 60, sir. I haven't really written it down, so I'm just...
Okay, so you think it's 60. So when you created X, let's do it by kind of working backwards here and say, to make X, we need to work from here and work backwards. So we're going to to create X, we need these two lines DB and DC. Therefore, we've got a chord that joins B and C. So these 2 points in the circumference, we can join with a chord. If we've got an angle that's between the tangent and the chord, which we very much do over here, this 60 degrees here, then it's equal to, you kind of go to that opposite side, the alternate segment, and that would be the same as X. So completely agree with you. X equals 60 degrees and tan chord is our reason. So that's kind of, and as you get into these, you're really just going to get into this in terms of that idea of, here we go. Here's a chord, the angle between the tangent and the chord, and then you'll create this visualization of going to the opposite angle like that. And trust me, I'm sure some of you are saying it and going, yes, I get this. And some of you are going, oh, not quite sure yet. But as you're doing it, you kind of get comfortable in using that. So those are our 3 theorems. And so let's just work with B as your one question to do. Let's double circle it for that and make sure this is saved so you can see which questions to do on the website. But you'll note either the first or the second, we either did it together or it's the next question. Okay, how are we looking? That was quite a quick run through, wasn't it? Or did anyone think that was a bit slow?
Perfect speed.
That was fun.
Perfect speed. Okay. And I must say, part of, I don't know, I'm cutting you off before everyone's had a chance, but it's always a bit of a range in geometry. Sometimes it might have been better to go, here we go, here are all the theorems, see them all, and then just go wild and apply. Or we've kind of done a bit of a hybrid approach where the first few we went a bit more slowly and then picked up our speed. Now you've got them all. So now you can apply them all, and then we'll get to more interesting questions. Look how they start getting a little bit juicier and juicier. but all using the same theorems. And the one thing we're going to do next term is this idea. Look how different question P looks, where it says, if this is 2x, find other angles that are equal to x, or prove or express things in terms of x. So that's what we want to do next term. And it's quite nice. We've got this lapsed time. So things you've practiced now, they can settle. And then when we hit it next term, it's the same idea, but just proving things. And I'm busy circling things and not sharing that part of the screen. Well done, me. Okay, but there were questions that ask you to prove things as opposed to just find out what the value of x is. 9 minutes left to practice. You can probably finish all of those questions in the next 9 minutes. I back that you can do that. Questions before we go off, because this is it. Remember, exam checklist is on the website if you want to see what topics are in the exam. And a huge thank you to Dr. Sampson, who he's cut out all the questions that are needed for your exam. So because we've done things in a different order and our exams are a whole lot shorter, he's cut out the bits we need. So if you go to exam on our website, you'll see the checklist, and I've embedded the last four years of exams, and he's just cut out the questions we've done, and he's even merged in the memo at the end of each exam. So start with those rather than going to the shared drive, because this has got all the stuff you need from previous years, as I said, with memo at the end. And I think that's, a really huge help. So big thanks to him.
So you said, do we have school tomorrow? Was it the
tomorrow you get to be a rapper?
So
it's rap day. So no, we'll call it rap day, call it SWAT day, call it what you like. There is no school, so I'm very sadly not going to see you at 2 o'clock on this Friday afternoon.
Sir,
Yes, Anande.
what are the questions that we need to do?
So I've circled them in our workbook. So those, let's run through them quickly. We were on cyclic quads. Exercise 8B. Let me make a note here. Exercise 9C. 8B, 9C. Exercise 10, we're going to come back to it. It's good though. Exercise 11B. Exercise 12A. Exercise 13B. That's it.
Thanks, sir.
Oh. It's worthwhile. Okay, well, that's it. Other questions, comments before you head off and carry on with circle geometry and then into, revising for exams or big test or assessment, whatever we want to call it. The real point is that we're consolidating this body of work we've done so far this year. Your question might be goodbye.
Thanks, sir.
Sure. Goodbye.
Thanks, sir.
thank you, sir.
Thank you, sir.
Thanks, sir.